Hello, this is Matt Oswald, and I'm here to talk to you about a few things with respect to software development environments. I've seen a lot of talk on Twitter and a few blog posts about some network engineers that are getting into software development and learning how to write code, and I figured I'd release a video and then also a blog post, which will be in the description for this video, on essentially how my particular development environment works, some of which will be specific to the language that I develop mostly in, which is Python, but the purpose of especially the blog post is to focus on the concepts. So definitely check the blog post out. It'll be in the description of this video. And you'll see some of the concepts that I won't be able to talk about here in this video. This video is mostly focused on the specifics of running the development environment within using a few tools that I've come to know and love, that some of you may also have some experience in, but may not really know how to use these in a software development context. So the purpose of this video is to sort of provide a spin on those tools, such as Vagrant and Ansible, that is conducive to a software development workflow. So the first step is I want to point to a GitHub project that I've put together to illustrate this called Mega Awesome, and it's just some BS name that I came up with to illustrate the value of automated development environments, which is really the main point that I'm trying to drive home here, and that is development environments are really necessary for reasons that I sort of explained in the blog post, but just to briefly summarize, it's important to not write code on one platform and then try to deploy to another. You will, if you're serious about software development, you'll almost always run into issues there. And that's even with just you developing code by yourself, much less when you're on a team of developers, each of which has their own separate environments. It really just doesn't scale. So you need a dedicated development environment to at least test and deploy your code in, and to run it. But especially as you scale out to several people working on the same project, you really need to come up with a way to automate the setup of the environment that you're testing your code in, so that everybody's sort of playing from the same starting blocks. It's very important to do that, because if you don't do that, and all of your developers have to spend a large amount of time dealing with the overhead of setting up their environments, then you don't actually write as much code. Your output isn't as you're not outputting as much code as you normally would have. So this is really driving efficiency. This project Mega Awesome is just one example. There are many tools and methodology tools and techniques out there that you can use. This is really just one. It's obviously very focused on Python. There are similar tools to what I'll be mentioning in other languages such as Golang. Java has quite a few. There's really no limit to this. So please focus on the concepts and understand that this is just one example. So in order to get this working, I want to first clone this project. Let's grab the GitHub clone URL over here. We can just click copy to clipboard and then go over to our terminal and say git clone and then that URL. It's pretty small, so it won't take too long to download. Once that's done, we'll cd into that directory, and we can explore, seeing that everything is here. There's a few files that I'll sort of mention as we go along, but for now we'll just sort of assume that they're all useful. We'll sort of stumble onto them one at a time. The first thing that I want to do is point out the Vagrant file, because this is sort of the beginning of our workflow. We're going to be using Vagrant to spin up a virtual machine that is our development environment. Now, another thing that some people do is they deploy their code into Docker containers. And that's obviously an extremely useful way of doing this, because it sort of achieves the same mechanism where you're saying, I want to start with, say, an Ubuntu base image, and I'm going to end up deploying my code into that. So it's a really good way of mirroring that workflow that you have in production on your laptop. Not everybody's running Docker these days, and I think the Docker folks have actually done a fantastic job of outlining the usefulness there, so I'm not going to try to replicate that. What I'm trying to do here is use the traditional virtual machine tooling and sort of get you guys introduced to the concept of a development workflow that way. But I definitely do encourage that you take that further with a Docker file or with deploying your code maybe into Kubernetes. These tools are going to be increasingly useful over time. So Vagrant's going to take care of spinning up this virtual machine, and the Vagrant file is a description of what that virtual machine should look like and what we should do inside of it. It's pretty simple. Just to summarize this Vagrant file, all it does is it downloads this base image from the internet. Ubuntu hosts their Vagrant machines on their own site, so we'll just simply download their image there for trusty. We're also mapping a shared folder here. Now, Vagrant does the shared folder redirection by default, inside of the VM, it's actually going to have /vagrant, and that the contents of that directory will actually be the same directory as this vagrant file is located in. So at /vagrant, all of these files will be there. So that folder redirection is possible. The reason I have this line in here is because I want it to use NFS. I don't believe it uses NFS by default, so I've sort of always done this. And we'll see where that comes in handy shortly. It's a significant performance improvement, and there's a few other things that we do to improve performance in that directory as well. And then finally, this big block is actually the definition of the virtual machine. Now, you normally probably would want to define some RAM and CPU requirements. I've left these blank so that you can sort of define these on your own, but if memory serves, the defaults are pretty small anyway, so it shouldn't matter too terribly much. Obviously, if you have a large application, you might want to tweak this. But we're provisioning a private network with DHCP. All of this is sort of under the hood. The main point of this is actually here, where we're provisioning the details of what this virtual machine should look like within the OS using Ansible. So Vagrant's going to take care of setting up the virtual machine for us, and then once that's done, once the virtual machine is up and running, Ansible is actually going to reach in and do some tasks for us. So now is the right time to actually look at that, because we actually have an Ansible playbook in the same directory that illustrates those steps. This is also very simple. I kept this simple so that you could see an example of this, but trust me, the full features of Ansible are available for use here. You can use as many interesting features of Ansible as you're accustomed to if you're used to this. Ansible roles, dynamic inventory, anything that you want. I only kept it simple here so that you could, to sort of introduce you to this concept. If you look at the tasks, we're doing just a few things, but these are all very important things, especially for software developers, because the one thing that software developers need is, very rarely are we writing things from scratch from a binary perspective. Most of the time we have software dependencies. We need to import things and reuse code, and those things need to be present on the system if they're not already. So these tasks are aimed at doing that, and this is a very common task, especially if you're writing, say, a Python project. You want to be able to have certain prerequisites installed that you're using. The first step is installing the 3 prerequisites that we need that are in an apt repository, namely Python pip, which is a Python-specific package manager. We're also installing Python dev, and we're installing Git. These are all things that we require inside of the virtual machine, and by stating them here, Ansible is going to install them for us. The pip dependencies are also important because these are, again, pip is a Python-specific package manager, and we want to take all of the pip dependencies that are specified in requirements.txt. Notice that I'm using that /vagrant directory that's already there, so that's sort of mapping to our repo. All of the packages in requirements.txt, I want to install those in the virtual machine. And then I'm actually explicitly saying I want to install tox. We'll see what tox is here in a second. But now, before we sort of continue along, what I'd like to do is actually run the Vagrant up, which instantiates this virtual machine, and then, of course, at the end of when the virtual machine is finally running, it will call Ansible to do the provisioning tasks, all in one. So let's do Vagrant up. You'll see that the base box trust is 64. We've already downloaded this because I've done this multiple times, many times actually. So normally you would see sort of a file download here of the image, but once that's done, it will import it. As you can see, the virtual machine is being set up, and Vagrant is taking care of all of the SSH key exchange so that we can do that. What I'm going to do is pause the video for now, and when we come back, I will show you what went on in the initial Vagrant setup. Okay, so our Vagrant machine, or rather a virtual machine, has been spun up using Vagrant. Vagrant has also called out to Ansible, which is the tail end of the output that you see here. So once the virtual machine has been spun up, Ansible will be called and the playbook will be run. And this is the output. As you can see, all of our apt dependencies have been installed, the 3 packages that we listed there, as well as all of the pip dependencies from requirements.txt and the explicitly named tox. So basically, I think there's only one package in our requirements.txt file, and then there's tox listed separately. I do that normally because I don't actually want to list tox in a text file. I can actually show you that. The requirements.txt file, yeah, it just contains the DeLorean package. Incidentally, I'm not using the DeLorean package in our in my code, but it's there because I want to illustrate how to download a dependency. So we could use it if we wanted to. Now, the next step is, so I have a virtual machine, And the cool thing about Vagrant is it allows me to do a few things. First off, the folder redirection is really, really nice. But before we get there, I'll just mention the SSH keys have already been exchanged. That's part of what Vagrant does automatically. So regardless of our back end, which happens to be VirtualBox, but it could be something else. It could be ESXi, it could be OpenStack, it could be anything. But for now, we're using VirtualBox. All you need to do is type Vagrant SSH, and you are immediately dumped into the virtual machine. And if we do an ll/vagrant, you can see that the folder redirection is working. All of the files that were in the directory where the Vagrant file is located are also in here. It is the same directory. Now, the thing that we want to do first is I'm going to set up a command that I like to use. This is not always necessary, but for performance reasons, I like to do this. The folder redirection here is useful. But there's a cost that is incurred when you read and write files in the shared directory, and Tox does a lot of things with specifically Python's virtual env to set up dependencies, create virtual environments, and do all kinds of things with respect to managing those environments for testing purposes. And that's pretty I/O heavy. So what I usually like to do is first cd into the main home directory for this user, Vagrant. Incident. We're actually already there, but as we'll see in a second, that I want to make sure that we're in that directory. And then I want to do a double ampersand to append a second command onto this. I want to force remove recursively the mega awesome directory, which doesn't exist yet because this is a fresh VM. But again, bear with me because there's another part to this. Another double ampersand. What we're going to do here is we're going to do a CP for copy recursively, and we're going to take the entire contents of /vagrant and copy it into a new folder called mega awesome. Make sure I do the double A. There we go. So that's done. And then once that's done, we do another double ampersand to cd into mega awesome. Okay, so when I run this, it's basically going to do, in plain English, what this does is it says, I'm going to take the code that exists on my laptop, meaning the code that's here in our browser, or in Sublime Text, which is the editor that I'm using for this illustration, because I want to be able to edit my code in Mac OS X, which is the operating system that I'm using on my laptop. But I don't want to run my code on OS X because OS X is not a production operating system. We're not actually going to be running this code in production on OS X. So how do I bridge the gap there? This is the way that you do that. Through the shared folder, or the folder redirection that we have, and using this command, I can copy the code into the virtual machine. Now, this is one direction. This is not one direction, not the band. This is a unidirectional copy of our code into the virtual machine. Normally, we're using this workflow, we're not going to be editing our code in the virtual machine. Otherwise, we would have to figure out a way to copy code back into the /vagrant directory, which obviously we could do, but this particular workflow that I like to use allows me to use my native operating system OS X, on my laptop to edit my code, but I can still run it within this virtual machine that mimics production. So sort of best of both worlds. So basically, whenever I change code on the laptop here in Sublime Text, all I have to do is hit up enter, and the code that was edited is now put into the virtual machine in this new directory because the old copy is deleted and it's copied fresh into the virtual machine. So before we move any further, I want to then, because the next step is to actually show how Tox works. Again, Tox is just an example of how you might use sort of a build tool to build your code within the virtual machine. Again, the whole point is to make sure that everything is automated. Before we do that, I'm actually going to intentionally break some of my code, and we'll see how it actually how we can fix it in the future. First off, I want to generate some PEP 8 problems. I want to make my code not PEP 8 compliant. So I'm going to put in, let's just say, import JSON. So I should get a white box in two places, actually, because I don't have enough spaces in between lines 1 and 3, and also I'm not using the JSON library, so it's saying unused import. So that's fine there. I also want to change the output of this time travel function to false. I have a unit test here on test_core where I'm making an assertion that the output of this function is true. See, assert true. So by statically returning false, I'm going to fail that assertion, which will produce a unit test failure. So let's do another copy, and then we can simply run tox epep8. Now, what Tox does, and it uses the tox.ini file that you see here in the directory for its configuration. I'll leave it to you because it's a little complicated. I'll leave it to you to look at that config file and see how that works. Essentially, Tox you can specify in the tox.ini file a list of environments to run, and basically what those environments are doing. So I have an environment, a section in that tox.ini file that's called pep8, and that section is designed to run pep8 tests, and it does it using two tools, flake8 and then also Pylint. Yeah, Pylint. So there's a Pylint RC file also in the repo. You probably are detecting a trend that I like to have everything in the repo. The reason for that is because all of my my software developers on my team, I like to have them have the same experience. I don't want there to be anything specific to my setup. So the more I put in the repo, the better. So what Tox does is it downloads all of the dependencies because I have it configured to do that. In the requirements.txt file as well as test-requirements.txt file. I keep those dependencies separate. That's pretty important because, for instance, what is it? Sphinx, so like automatic documentation. That's not actually a dependency of my software. That's only a dependency of the test framework. So I have those two separate text files. As you can see, we have some pep8 failures because of the changes that I just made. JSON imported but unused, and then also I've not done the appropriate amount of blank lines in between my the class and the line above it. So let's go back in and fix that. We can do that by just simply taking this line out. Looks like everything looks good from Sublime Text perspective, but of course we want to please Tox as well. So let's re-import our code. Let's rerun Tox pep8. And the one drawback of this setup that I've noticed, and I suppose I could figure out a different way of doing this, but because everything is downloaded into a virtual environment at .tox, you do have to wait a little bit for all these dependencies to get installed. It's actually not that big of a deal if you look at how slowly other things could possibly happen. But just FYI, by removing that directory, you're also removing the aforementioned dependencies that were installed. So you sort of have to download them fresh every single time. It's up to you if you think that's worth fixing. So you can see flake8 was run and also Pylint was run. And now that we have pep8 compliant code, everything is passing. So Tox is happy, and that's important because Tox will be run in production as well, or rather in our continuous integration pipeline. So we want to make sure that we're getting the same output. Also, we have a second environment called py27. This runs our unit tests. Again, this is all configured in tox.ini, so I encourage you to take a look at that. But similarly, this particular run of Tox is going to create a new virtual environment, namely py27 underneath the .tox directory. It's going to install all of the dependencies there, and it's going to run unit2 discover. And it's going to look in my unit tests directory for any unit tests that are there. And there's only one. And as I mentioned before, I'm making an assertion that the result of the time travel function is true. Since it's not, this unit test fails. So in order to please Tox once more, let's properly implement the function because we want to return true. Oops, I don't want to rerun pep8. Let's re-import our code, and then let's rerun py27. Again, just a slight delay. And I think I don't have the fastest of internet connections right now, so that could also be a factor. py27 is passing. Looks like all of our unit tests are good. One final step, let's run coverage testing. Again, a third environment, all configured in tox.ini. And it also installs the dependencies, and then it runs through coverage testing. Now, there's a few coverage tools in Python, and there's coverage tools in many other languages. But for those that don't know what coverage testing is, essentially what we're doing is we're saying what parts of my code are and are not covered by unit tests. We want to make sure that we're covering as much code as possible, or at least as makes sense so that we know that we're properly testing our code. So the coverage testing is performed using this eCover argument, and if you are interested in seeing the results of that, you could either look at the cover directory directly, so see llcover. You'll notice that we have some HTML files in here. We could install links, for instance, like a command line browser, but instead of doing that, I'll do a copy of this directory, cover to vagrant cover. So what we can do here is we can, as I've done here, I've copied the cover directory out to /vagrant, and basically that's our original directory for where the repo is stored. So all we have to do is go into a web browser and open that. And as you can see, we've only got 60% code coverage, and that's because we haven't written a unit test for this run function. But the unit test that we wrote for the class Mega Awesome, namely the function time travel, that's covered, and it's running every single time we run our unit tests. So that's good. So the moral of the story here is that I've fully automated the development experience, and I've done so in a way that allows us to use the tools that we want on our own operating system while still doing the right thing of deploying and testing our code on the operating system that will be running in production. So it's sort of the best of both worlds. We get the workflow that we want, and the more important thing is that it's automated, and then that automation is shared among our team members, because every single artifact for how the automation takes place is in the repo. There's not a specific configuration in our CI pipeline. It's all in the repo, and that's very important. So thanks for watching, and if you have any other questions, feel free to visit the blog the blog URL that's in the description for this video. I have a comments section there. Feel free to visit and ask any questions or for clarifications. Thanks.